In today's video, we're going to be talking about the different types of AI models that there are available. So many of you have asked, there's hundreds of different models out there, which ones should I be using? So most likely you've been to huggingface.com before. So if you look at the very top, here is models, and I'm on this page already, but you can see there are many different types here. So there's more than just the GPTs of the world, but there obviously are a whole bunch of use cases that can be done with them. So I'm just going to talk through what some of these things are, just to make it easier for you guys. So text to text, or well, text to image, I'm sure you've seen for Stable Diffusion. There's obviously many libraries out there. Stable Diffusion XL is probably the best one when it comes to creating images that's open source. Think of this like Midjourney or DALL-E, which is OpenAI's version. This one's completely free. You can download it, use it on your computer. I'll do a different video for how to run some of these models if you want it. Image to text, this is captioning. So Salesforce, you might be surprised to see their name. They did Blip, which is you take an image and it will give you the text for it. So this is great for stuff like writing alt text for within your website posts, and obviously like give it a go, have a try. Text to video, sorry. So actually what's most popular for this is Runway ML, but you can see, I don't know why this is loaded up for text to video. I wouldn't say that Llama 2 is for text to video. I think this has maybe messed up the interface. I must have double clicked. Yeah, there we go. So I don't have much experience in this. Like, have a play. That one's obviously the most popular, so it's probably the best. Visual question answering. This works in exactly the same way as image to text does. It's so you can ask questions about the image. So where Blip and Clip are designed to say, this is an image of a cat. This one you can say how many cats are in the image. So yeah, you can see Blip VQA, and then it will answer those questions about it. This is really great for doing some advanced machine learning to find out extra things about your data set. So document question answering. This is very similar to picture question answering, except for a document of text. A lot of the time, these will be using a combination of text embedding, which is converting text into a vector, and some kind of text generation model. So quite often GPT is used because it's open source. It can be quite small. I couldn't tell you too much about graph machine learning. Computer vision, obviously this is great for doing all sorts of things. So depth estimation is to tell from a 2D picture how deep into the picture an object is, so you can make 3D models from 2D images. Image classification, this is a dog, this is not safe for work. Hot dog, not hot dog, I'm sure you've know about if you've watched the show. Object detection, this is like find Ashley or find the dog in the picture. Image segmentation, this is when you have an image with multiple things in it. So let's say it's a picture of a person. You might click on the person and that would cut the person out. So it would identify the edges of that item, that entity within the picture, and help you do it. Image to image, quite famously you've probably seen in painting. Midjourney have just rolled that out. Stable Diffusion have had that for ages, and that is based on this image, give me another image. So you used to have things where you would combine two images, so take Arnold Schwarzenegger and a peacock, and then you'd have a peacock that looks like Arnold Schwarzenegger. Unconditional image generation, I'm not actually sure, but I guess that's it makes an image based on its own decisions, so you don't give it any inputs. Video classification, same as image classification but for videos. Zero shot image classification, so sometimes when you create things you will give it a predefined list of things. So when it was trained it might know about peacocks and robins and other types of birds, chickens, whereas zero shot is I could give it a couple of things that it's never seen before ever in its training. So this is an apple, an orange and a pear, and it will try and classify that particular image into one of those categories that we've given it based on what it's learnt previously, but it's not necessarily been trained on this thing. Text classification, this is much the same as image classification, except it will classify the text. So you might have a message come in from someone and you might try and classify it into buckets. So say this is a support request, this is a sales request, this is whatever it might be. Token classification, same thing, but just a smaller portion, i.e. a word, not quite a word, but a token. Table question answering, does the same thing for tables. Question answering, that answers questions about the text. Zero shot classification, again, that's the same as the images, but with zero shot. So I've never been trained on particularly identifying birds, I've never been trained particularly on identifying peacocks, but I might have seen birds versus monkeys before, and I might be able to figure it out. Translation, I'm sure you can figure out what that does. Summarization, so this AI model will take a whole bunch of text and summarize it. You've probably seen this done with ChatGPT millions of times, but these were the original ones. So Facebook, in their defense, have done so much for the open source community. People don't give them credit for it. But BART is a very commonly used library. It's great for all sorts of stuff, and this is trained on the CNN dataset. That is conversational. This is obviously, rather than generating text, it's more about replying as if it was a conversation. So again, ChatGPT has made this very much a household name now, but originally text generation was the thing. So what would happen is you would start writing some text, and based on all text that it's seen before, it would write the next things. Conversational is it's just formatted that text in a certain way. So I'm going to touch on some of the text generation models here. So as I'm sure you've no doubt seen, Llama 2 exists. Llama 2 is fantastic. Llama Code, I think it is Code Llama, exists. That's obviously very good too. ChatGPT exists. Bloom exists. That's a huge model, but was pretty good back before all of the newer stuff came out. You notice a lot of these have these different 34B and 7B, 30B, 70B. That relates to the number of parameters that the data has been trained on, or the model's been trained on. So this might be a parameter. Wow, that's a token, sorry. That might be another token. That might be another token. That might be another token. And the parameters are all the different combinations of orders that it's seen those tokens in. So I want to touch on some extra stuff with this. So you may have noticed, or you may have found before, the Hugging Face Open Large Language Model Leaderboard. I'm not going to search it because it takes a while to load up, so I've just preloaded it for you guys. But this is where you want to come if you're looking at text generation AI models, because this is what's winning in the open source community right now. So Uni Tianyan, I don't actually know that. That's new since I last looked. I guess it's the Chinese model. It literally must have only just come out. But this is winning. This is currently the best model, so it's a Llama fine-tune. This is currently the best model in existence right now that's open source as per this particular testing dataset, but this is a pretty good testing dataset. As you can see, everything's been done against it. People are always submitting stuff to it. I've turned on this additional column params because this actually shows how much memory it needs to a certain extent. So you notice that this is 9.7, but actually it says 70B over here. Why is that? And the reason for that is it's got this GPTQ on the end, and GPTQ is actually a type of quantization. So quantization is, how best to explain this? So if you imagine, if you know any binary, you know that you've got ones and zeros, and this here is 8-bit, and if I could be bothered to type it out, you could get 16-bit and 32-bit. So a standard integer is 32 bits, I believe. Standard integer bits. Yeah, 32 bits is a standard integer. So what these clever things do is they try and put it down into 8-bit or even 4-bit in some instances. And obviously, as you can imagine, if I've got 32 bits, I can have a huge number. But with only 8 bits, like I've gone from, hang on, max int size, I've gone from that many, which is 214 million, to only 127, or maybe it might, I think it is 8-bit, but yeah, so as you can imagine, let me just zoom in for you, and I'm in the way, obviously. So that's quite a decrease in accuracy, in precision. So as you can imagine, that can lead to worse quality. But at the same time, it obviously uses a whole lot less memory. And using less memory is sometimes something that you want, because you might not have a computer powerful enough to run whatever the 70 billion parameters is. I think that needs about 40 gig of RAM, of VRAM, sorry. So it's interesting that you need to make sure that it can run on your computer. So GPTQ is specifically, I think, for NVIDIA, but it massively shrinks that model size. So as you can see, from 70 to basically 10, that's a reduction of like 7 times. It's fantastic, it's great. There's also an additional thing to this. So there's GPTQ, but there's also GTML, which probably won't feature on this, no. But if you look in the model page, we'll probably see a GTML at the top. So while GPTQ is for graphics cards, GTML is for CPUs. So it's the same sort of thing, it's just been quantized, but it's been done in a way that supports CPU. So if you don't have a graphics card, you can probably run that model. And the fact that it's 7B, it's going to use even less RAM. So that'll run even on a MacBook that with no graphics card. Sorry, people with Macs. It'll run even on something with non-dedicated compute unit hardware. So that was quite a massive tangent, but hopefully you understand why. Text to text, take some text and convert it into something else. Flan T5 and just T5 in general, great library made by Google. If you're going to use T5, use Flan, it's the slightly better version. Ultimately, it's used for things like summarization, it can also be used for classification, could be used for translating. It's really flexible. So it basically takes some text and will produce some output. So you can see quite a few things in this example here. I've trained custom models with Flan. It's really good. Like, as long as it's doing a specific use case, think of it like fine-tuning GPT-3 that everyone's excited about at the moment. It can do that. It's great. I don't know why music gen is in the text-to-text. As you can imagine, music gen creates music. Really good. I like it. It's made by Facebook again. Facebook honestly does really good stuff for the open source community. Phil Mask, Roberta or Bert, these are made by Google, I believe. So what these will do is, if you've got a string of text and a missing character in it, so the mask token might be mask, you might have, I don't know if you can see that, you might have hello, or hello, the weather is very masked today, and this will try and guess what the mask is based on what the most common words are. So this is what happened before text generation really became as big as it was, because people were just trying to solve this very simple problem, and then obviously things escalated and we discovered that we could produce really huge models. So here you go, look, the weather is very nice today is the most common thing that people will say. Couldn't have guessed. I've zoomed in way too much now. So where were we? Sentence similarity. This is actually where text embedding comes from to a certain extent. So sentence transformers is a collection of libraries. It's not specifically made by them. That one's probably the one that I would recommend you use, or use the OpenAI text embedding. And this will basically say, given this sentence, a string, how close is it to this other string? So when you search for things, so this will be a great example of an exact match. So I'm going to search for sentence transformers. So if I misspelt it, that's going to find nothing because it's an exact match. Whereas if I use sentence transformers, well, sentence transformers not so much a fuzzy match actually. But so I'll tell you what, if I was to search for dog versus if I was to search for mastiff or bulldog, like sentence transformers would find the result for that. So obviously not in models, but in Google you can see that dog finds dog, but bulldog also, I know it contains the word dog, but they're similar, they're semantically similar, and also it's just really good for, it's also good for question answering. So I might ask, how do I cut my toes, and then it might match with an article about here's how you cut your toes, because they're similar. So moving on, text to speech. I'm sure we can guess what this is. Sunobark is probably the best library that's out there right now that's open source. 11 Labs is obviously the best closed source AI model for text to speech. Both of them are really good. I don't know if there's actually any examples on here that I can show you, but if you go to their GitHub, there's some fantastic examples of stuff that like would blow you away. Like really good. Speech recognition, I mean, Whisper's probably the best, yeah. OpenAI have open source something for once, finally. But Whisper's fantastic at doing speech recognition. Actually, I've seen people get Whisper Tiny running in browsers. Like, it's insane. Like, I don't know how big that is. Probably like 50 meg or something. 150 meg, yeah. But I've seen people get Whisper running in a browser. It's fantastic. Really well done. Audio to audio, that is take something and change it to a different type of audio. I'm sure you can guess. Audio classification, same again. Activity detection. So if you think of your Amazon Alexa, I don't want to say it too loud, but when she wakes up because she hears the correct thing, this is that same sort of stuff. Tabular classification, I would guess is just doing stuff in a table. Reinforcement learning is where stuff gets really cool, and that is how we train machines to like play, yeah, Space Invaders. I was going to say play Mario, but it's done by when the machine takes an action that you want, it will be rewarded with a point, and when it takes an action that is unwanted or just sits there and does nothing, it will lose points. So you stick it in a game and it will try random things until it does something that increases its score, and it'll be like, oh, doing that was really good, so I'll try and do that again. And that is how they've trained machines to play stuff like League of Legends, etc. And it's amazing. And that's literally how you can get a machine to do anything, but obviously it takes a long time because it's trying at random until it finds something that makes sense. But I mean, that's really cool. Like at the end of the day, if you want some, like that's how humans learn. We learn by trying, and that's ultimately how we've ended up being the clever species that we are today. So anyway, that is a very long but hopefully quite insightful rundown of all the AI models that are out there today. I've touched on some of the better ones, and hopefully I explained why some of them exist. I know it's not necessarily my usual content, but people have been asking if they were interested, so I thought I'd do a presentation on AI models for you. Anyway, I'll catch up with you soon.